first debut and or guest spot. We're going to find out how it goes.
Thanks for joining us, Greg, today. Pete is actually, I think, up watching the two of us. He wasn't sure what his schedule would be like this morning, and so we, the two of us got together and said, we'll take it. Don't worry about it, Pete. So we have a lot of stuff that's going to go on today. I'm going to have you take some time, Greg, and talk a little bit about yourself, reminisce a little bit on history. We're going to have some fun with that. Then we'll get a little more into fiber optics today.
Mark and I wanted to at least start off by going through a history of technology and where it has come from, at least from my age. We won't go down that path, but some of the things I've seen in my career. Last week, as an example, Pete talked about his early days at DEC, Digital Equipment Corporation, and that was in Maynard, Massachusetts. And about 15 miles away in Framingham was a company called Prime Computer, and Prime is really where I started my my career.
Mm-hmm.
And at that time, both companies were making large mainframe computers, the green screen.
Hey, Greg. Sorry to interrupt you. I just need you right up on your mic if you get a little closer for me.
No problem.
Thank you.
All right. Sorry about that. So both companies were making dumb computers, and as Pete showed you last week, the 80 meg hard drives, which were big as a washing machine, and crashed quite often because the platters would get a little speck of dust between the heads and the platter. But that's where we both grew up. At the time, Prime Computer's claim to fame was building a 14-inch square, I think it was a 7-layer circuit board that had a whopping 128K of memory. Now, I'll let you guys go Google what 128K is, but they stacked all those boards in one chassis and had 1 meg of memory. And that was just absolutely phenomenal back then, and what those computers were capable of.
Oh my gosh, yeah. And of course, at the time, they weren't called hard drives. They were called DASD storage.
Okay.
Direct access storage device. And that's because you had either that or you had tape storage. And the direct access was faster because you could jump around in different spots. It wasn't sequential storage.
And the tape was what looked like big reel-to-reel tape drives.
Oh, yeah.
Did all the backup from there. So that was Prime and DEC for Pete and I. We both have talked in the past about, our two careers, starting off in Massachusetts and what got us back out here. But shortly after that, I ended up at a company called Autographics in Waltham, Massachusetts. And Autographics was one of the first companies doing slide presentation graphics, and really it is not far from what Microsoft PowerPoint is today, long before PowerPoint ever came out. And so back then, the presentations that any of us had to do in business were done on clear film that you got to put on an overhead projector, and it was just plain black and white. Well, this company introduced color graphics and bar charts, and way ahead of its time until Microsoft took over. But even then, the people that created these slides and everything we did was done on Apple IIe's back when they were first introduced to the market. Jesse, do you have that picture of an Apple II?
Yeah, let me throw that up.
There we go. And that was leading edge, bleeding edge technology back then. And those two drives in the middle each held I think a 5 1/4 floppy drive that went inside of it. What was the memory on those, Mark? Do you remember?
I think those were single-sided drives, and so they would be 180 kilobytes per 5 1/4-inch drive. And then now later on, of course, 5 1/4-inch drives, they had this revolutionary technology change, and they went to double-sided.
Indeed, twice as much. One of the jobs I had at Autographics was the customer service side of the business, and we sent out a new software update to our customers, and I had a lady call up and say that her disk was trashed, broken. She couldn't read anything on it. And she told me that she was really careful to hold it by the special thumb and finger hold on the side of that disc. And so I told her to go back, grab that disc by the finger hold. These were even the next generation
And, yeah,
technology.
these aren't even the right generation, but the 5 1/4" discs didn't have this protector on it. They just had the area right there.
Yeah, for the disc. But I told her to grab that by that special finger hold and go drop that in the trash can, and we'd send her out a new version. But again, that was the leading edge technology back then. And anybody that had an Apple II in their home or in the office was pretty styling. Did Apple come out before Compaq and Dell did with these?
Yes, just by a little bit. In fact, I remember, I'm dating myself here, but oh well, our counselor's office in high school had an Apple IIe, just about like what we had on the screen. And I got a copy of a magazine, and that magazine had 4 pages of machine code. The promise was if you typed in the machine code, at the end, it would give you a check digit, and you get all the check digits right. After typing in all 4 pages of machine code, you would have a spreadsheet program. And so I was able to successfully do that, actually. And man, working on a spreadsheet, that was like considered pretty cool.
Pretty awesome. But even then, from the Apples, people had to use a office phone that would hook up to a modem. And at the time, I think it was 300 baud modems that everybody used, and made this really funny beeping sound, not dissimilar to faxes way back when. But that modem would actually connect to a bank of modems we had in our office, and then they would download those files. We would transfer those to a film recorder, 35 millimeter film, have those developed, and then sent off to a lab to be developed, then overnight them back to the customer for their presentation. It was a great company, great technology, but again, the big companies like Microsoft just came in and wiped them out with the software that we all use every single day. So 300 baud modems were the first pass, and then where do modems go from there, Mark?
Well, from 300 baud, they went up to, I think they went to 1200 next.
Yeah, 300, 600, 1200, 2400.
Yeah, then they started going up by 2s.
Yeah.
So 1200 to 24. They kind of skipped 48. I don't remember seeing a 48.
9.6 or something.
They went to
like
the
that.
9600 baud modem. And I remember doing a lot of work as a computer consultant over a 9600 baud modem. Had this little box about so by so by so, and plugged my phone into the back of it, and I mean, it was like a $500 modem. It was not cheap at all. But that's how I would support my customers that needed their accounting software taken care of. You know, and if I had to update a program and I would upload it onto their system to do that, you know, I mean, I would start the upload, and if it was one of the bigger programs, it might take 30 or 40 minutes. And these would be, if a program was as large as a megabyte, that was the one that would take 40 minutes.
It would crash it.
Yeah, it could crash the modem, and that was a real problem. And the other real problem was, of course, if they were using that newfangled Windows, and and these little dots that go across the screen, and to do a screen refresh might take 15 minutes.
And I think even back then, the quality of the phone lines that companies were using was rather suspect. And so if a phone line just dropped the call for any given reason, you had to start all over again and retransmit. So again, that was the technology that we had. Pete talked about this in the beginning days of Gruber and what he had for a dial-up ISP. And that was the technology that he used and we used. It was fun and exciting, but boy, have things changed since then.
Boy, have they, I tell you what.
Then obviously the whole mainframe market sort of, not tanked, but it stopped at that point. And companies like Dell and Compaq just came out of the woodwork with a better idea, IBM, another one, with their desktop computing. And the computing power inside of these desktop systems just kept getting incrementally faster and faster. We were joking earlier about if you had a, I think it was 386 computer at home, boy, you were styling. You were on top of it with the latest and greatest and fastest.
And I do remember one of our offices that I worked at bought a compact 386 computer, and it was $7,500 for that silly thing. It was so expensive. You know, I just put another image online. I'd like to have Jesse throw up as well. It's called Phone Modem, and it is a good picture of what that old style modem used to look like. There we go. Rotary dial
Even
phone.
a rotary dial phone.
Rotary dial phone and everything. But you know, you would take your phone off the hook once you dialed the number. You would put that phone onto those two rubber things so that they would block out the extra noise, and hope that you could get a good connection.
Even with phone technology, rotary is what I grew up with as a kid. Then everybody started, this new technology called push button, which is what most of us enjoy today, if you even know what a desk phone is or a house phone is. And but yeah, going from rotary, actually growing up here in Phoenix, we had even party lines on a rotary phone. So it wasn't a direct line to your house. It was, you'd have to pick up the phone, and if anybody else was talking in the neighborhood, you had to hang up and wait for that call to end. The phone technology is yet another thing that has just blossomed in this country.
And if you were, if you picked up the phone, I remember that as a kid. One of our, we had a string of neighbors that had a party line, and if you're talking to somebody and suddenly you hear us tick 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 tick, you'd be like, "Hey guys, you need to wait. We're on the phone still."
Indeed. Oh, fun time.
You know, before we go further, let's take a quick. I wanted to tell people about the background that we have. This background is a Mid-Journey special. It's supposed to be what the data center of the future might look like, as far as cabling goes. I happen to really love all the rainbow colors on the cable. I think it's a cool look. I can't imagine a manufacturer that would actually want to extrude rainbow colored cables like that.
It's pretty bright colors, that's for sure.
And I think you were mentioning too, kind of a mess.
Yeah, it is not what I think the data centers today would look like, or at least your higher end co-location facilities that we sell a lot of product into. But it's what did Pete say? It was an AI generated picture. So that's what AI gets us.
But it's
pretty cool looking.
It's a pretty cool looking picture. I have to admit that. We have a couple of comments here. One on IT manager from YouTube saying that this picture of a phone and modem looks like an acoustic coupler at 1200 baud tapping into a DEC 10 mainframe.
It could be.
It very likely could be something like that. And then Audrey Taggart, she was guest on our from us from 2 weeks ago, and says, "I love the background." Thank you, Audrey, for joining us.
Very good. So anyway, out of that, I ended up going to a company called Interland out of Boxborough, Massachusetts. And Interland was, at that time, really one of the pioneer Ethernet companies. One of the things that they started to sell was 2 meg Ethernet over thick coax cable. And they had these special end tap connectors that you had to drill down through the shield and then get to the core of the cable. And if any of that was touching, it would cause collisions and bring the network down. But then they migrated over a long period of time from 2 meg over thick coax to thin coax. And then, as Pete also talked about last week, they started to be able to use the 4 wires that were inside of the wall, the old POTS wiring, and be able to transmit, and I can't remember, it was either 2 meg or 5 meg over the two twisted pairs that were sitting inside of the wall. And that, as Pete talked about, really was a huge game changer for this whole networking explosion. So Interland was really founded by a guy named Paul Severino, and out of Interland came two big companies. One was called Wellfleet out of Massachusetts, another routing company that competed at the time against Cisco, and we know who won that battle. And then the second one was a company by Craig Benson called Cabletron, and I ended up going up to Rochester, New Hampshire, and working at Cabletron for a number of years. Just an outstanding company, networking company, very much like Pete. They started off just selling cabling, but then they were had a brilliant guy running engineering by the name of Chris Oliver. And Chris designed a number of leading edge technologies, much like Pete was talking about last week with Twisted Pair. But one of them was called the Lanview LED, and it was a special, Jesse, if you could bring that up. There we go. And so a lot of companies were already creating these taps, and we had gone from the coax drill down through to a BNC type connector. The other side of these typically had an RS-230, DB9 or a DB25 connector. But Chris was smart enough to put in all those LEDs. And when that got connected to the network, it told you whether there was power to that device. It obviously gave you all the transmit and receive functionality that most of the other transceivers were 100% blind to at that time. And so Chris designed that not only into the transceiver, but also into all the NICs they made to go into every computer, the Dells and Compaqs, IBMs at that time. Today, we all are spoiled by having an Ethernet connection on our computers that we can tie into the network. But back then they had to open them up, insert a special card into those computers so that they could actually tie into the network or tie into those transceivers.
So in other words, you're saying that these lights that would flash and flicker and stuff to show the activity on the land are kind of the precursor of what you see on the lights on all the network cards today that are sitting on servers and stuff.
Absolutely. It was a great troubleshooting tool right out of the gate. And so those were the kinds of innovations that Cabletron and Chris continued to develop and offer into the network. But even in the early days of the Ethernet market, there was still other technologies out there that were all vying for first place. Things like Novell out of Provo, Utah, had their own operating software. Another company out of Massachusetts called Banyan Vines. There was AppleTalk, there was Token Ring, Frame Relay, ATM, which is asynchronous transfer mode from a company called Four Systems. And they were all great technologies. They all had their pros and cons, but over time, they all ended up falling to the wayside because Ethernet is the one that won.
You know, kind of a side note here on Banyan Vines. One of our former IT managers, a gentleman named Daryl Renard, worked here at Gruber for many years. In fact, Daryl and I met each other probably 3 or 4 years before he started work here at Gruber. And when he left, he went to go work with Disney. And the reason that he went to go work with Disney, he knew Banyan Vines. Up through at least the late 2010s, Disneyland ran on Banyan Vines, and it still might run on it to this day.
That wouldn't surprise me. A lot of these older legacy companies have so many of their systems tied into some of these old operating softwares and technology that it almost becomes insurmountable for them to break away and morph into something different. And again, as we talked about, from Interland and then all the way up through Cabletron, the Ethernet market just continued to explode, where we started off really doing what's called 10 base T, 10 meg over copper. And then it went up from there to 100 base T, gig E, on and on, faster and faster speeds. And Cabletron, like Synoptics or anybody else at that point, the other networking companies really were the instigators of putting all these switches Mark talked about inside of the wiring closets, pulling all that copper back, hooking up fiber between the wiring closets for high speed. And again, that networking market just continued to explode, literally one step in front of them. It's a very fun. I've spent 7 years. It was a great ride.
Yeah. It definitely sounded like you guys had a lot of fun, a lot of things going on there, and cutting edge for the time technology. I can remember working on Lantastic stuff and Token Ring. Lantastic was based out of Tucson here in Arizona. And so they had their Token Ring networks, and that would be part of what we would work on. At the time, I remember the topology was the talk of the town. Whether you had Banyan Vines, which was like it was like a multi to multi point. All computers are connected to each other, almost like a neural network, or the Token Ring, where everything is connected with that thick coax cable and the BNC connectors. And if you had 12 computers, they would just sit in a ring, and every computer was kind of self-managing as far as that went. And those were considered to be far superior overall to the star topology Ethernet network until the network switch came about.
Indeed.
And then the network switch, which became a computer itself to help route traffic, it took all the load off the other computers. So yeah, it was, fun times. Good fun times.
So a comment from IT manager, it looks like our wire management products will be needed even in the future. Well, based on that screenshot we have there, it is. But they were needed even back in the Cabletron days, probably more so because there was so much wire going into all these wiring closets. Back then, a lot of these companies, they didn't design network centers or wiring closets to pull this back to. By and large, they were, if there was a broom closet, the brooms got thrown away, and that became the wiring closet for
it
a
really
lot of these
did.
companies to bring all this back into. And even back then, I recall that I don't recall ever seeing an enclosed cabinet. Typically, everything was what we still offer to the market of a two-post rack that all this equipment got bolted into and then punched down in the back and hooked up to all these servers and switches.
And we went from 2-post to 4-post racks when it came time to put the big servers on there, and we still use some of those 4-post racks. We still have customers that buy the 4-post racks as well.
Yeah, I think we sell, Gruber sells a lot of 2-post and 4-post to either startup companies, but even our installers install them every single day in a combination of, or even in the big data centers, the co-location facilities, they really become the demarc between the carriers and the floor of all the servers that are out there.
Right.
So that's where the Verizons and not the compacts, but the phone companies come in and drop off their demarc, and they're typically done in a special room on
So
a 2-post or 4-post rack.
Like the CenturyLinks and stuff like that.
Correct.
Yeah, and they do. And a lot of wall mount racks get used that way. Even seeing when Cox came in and upgraded our internet a few years back, they brought out a wall mount unit that I don't think it was ours, but I can't guarantee that because we do sell quite a bit of stuff to them.
Right. So again, technology just keeps doubling every single year and getting faster. After Cabletron, I ended up leaving and going to a company that was funded by Cabletron, along with Chris Oliver, the head of engineering at Cabletron, was my co-founder. But it was called Vitz Networks, and it really was the very, very beginning days of the internet. Back when companies didn't want the internet to even come inside their office because they thought people would spend all day playing. They didn't know where the explosion was going to go. They didn't understand the need for co-location for their servers, what e-commerce meant at the time. And today, you can't have a company if you don't have a web presence, if you're not selling stuff on the e-stores online, you're pretty much out of business. And the whole co-location market is part of what made Gruber Power also successful, because every co-location facility and data center in this country is backed up by UPSs as well. So that created the need for multiple UPSs, a high degree of redundancy and resiliency that went inside of these data centers that allow them to operate. And the reality is today, the internet never goes down. When's the last time any of us ever, did a Google search and not have, millions of results back in a second? Never mind the fact that if any of us ever went to Amazon and tried to order, the next thing that we absolutely have to have this afternoon, and we couldn't get on Amazon, boy, they'd be in big trouble.
Yeah, the way technology has gone has been amazing. First, seeing the little mom and pop shop that had the foresight to put together a well done website that shows this broad array of products that they offer. Okay, this isn't a mom and pop shop, or it doesn't look like it. It looks like as big a company as the behemoth down the street that sells all the same stuff. And it was, it was early on, was kind of a Wild West days of the web. Those people that could source products the best are the ones that ended up the winners.
Indeed.
Even fast forwarding to Amazon kind of taking over a lot of the e-commerce stuff, the same thing is happening. The people who can source the best and put stuff onto Amazon or put stuff onto the websites, they still end up looking as big and robust as some of these larger companies.
Absolutely. In fact, Amazon has a huge web hosting presence. And that is, where a lot of people go to.
Yeah.
And they all have redundant sites to be able to do that. Well, interesting thing happened to allow this internet explosion. It was something called the Telecom Act of '96, and that's where the federal government basically said to all the RBOCs, hey, listen, we don't like the monopoly that you guys hold, so it's time to break up the RBOCs for competition. It opened up the door for a new level of phone company called a CLEC, a competitive local exchange carrier. And that's where VITS came in and allowed us to co-locate all of our hardware inside of Verizon, or at the time 9X, New England Telephone's data centers. And then we leased copper lines from them to get out to the businesses or people's homes. And again, back then we were offering DSL, ADSL, but boy, the big boys were a T1. And if you had a T1 into your company, you were flying. And again, a T1 was a whopping 1.54 megabits a second.
I had one of those in my high school.
You did?
The T1 line, yeah, it was crazy. I was there when we got it put in. It was awesome. It allowed for our LAN parties to go a little smoother.
Yep.
Even though, one other thing too, real quick, I just did a quick search. I don't know how accurate this is. There's a couple different sources, but it's estimated that Amazon Web Services, AWS, serves 40% of all internet traffic.
Incredible.
Wow. I wouldn't doubt that though, Jesse.
So they're not pots and pans and coffee.
Yes. Another comment we have from IT Manager on YouTube, where he says, moving from point to point wire connection, wire connecting mainframes to dumb terminals, they migrated to patch panels to allow for troubleshooting and rerouting. That's an excellent point.
Absolutely.
I still remember in the first company I worked with, we went from a small Xenix system running on one of those compact computers to a DEC Microvax. And the electrician that we hired to do the wiring, because you didn't have low voltage cablers at the time, he went in and was talking about how you want to minimize the number of connections and stuff. So we wired from each of the terminals in one room. He ran them through the ceiling, down the wall, out and to the end of the deck in the other room. It was a direct wire though. It was computer across the way to workstations. And the idea of having some sort of a panel where you could have the computer that goes into a panel, and then that panel can go to your
Mm-hmm.
workstations, was something we had not really heard of yet at the time. And yet very shortly after that, we were doing those exact things. Get your wires, get all your connections together, put them in one spot, and then have one wire that goes to your mainframe or one wire that goes to your networked server.
Mm-hmm.
And it made so much more sense.
But even in the Cabletron days, everybody had jacks in their walls that you would plug your Ethernet cable to, and that jack would go to your phone or largely to your computer. Then back in these wiring cabinets, as that was pointed out, there were just banks of these punch down blocks that everything got terminated into, and then cables from there that plugged into all the switches.
And
So
you
great
know,
for troubleshooting.
a lot of that stuff even today, that's one of our specialties over in our panel
Mhm.
room, is putting together specialty patch panels, because it it's the to me it's the hardware equivalent of the COBOL programming language. COBOL is one of the very first programming languages ever created. It still is known to run mostly on mainframes, and it still is alive some 60 to 70 years after its introduction. It's a good, solid language that works. And the banks and financial institutions that are underpinned by COBOL don't want to change what works. So they're running on 60 or 70-year-old software. Same thing is happening on the hardware side. We still get people that have patching,
Mhm.
patch panels, even 25-pin panels for some of the specialty hardware that they use
We produce those every single day for our customers.
every day.
And every time we get an order for one of those or a T1 cable off of it, you got to scratch your head. And isn't that obsolete? No, it's not. They're still using it.
Yeah,
We
you're
still
right.
produce them for you.
We still produce a lot of them for people. And so, IT manager also said catalogs were replaced by websites.
Very true.
Oh my gosh, that's so true.
So VITS was another, as I mentioned, the company that I co-founded with Chris. And again, T1s were a just super fast connection to a business. Now, T1s were more than just a data connection. T1s also had the ability to carry 24 POTS lines to a business. That's really what they were known for. And then we migrated all those over to a data T1. And again, T1 sounded fast at the time, but it wasn't fast enough as companies really started to buy in on the whole e-commerce and email, and as Pete even talked about, the whole fax servers. But every company just really started to buy in on this new technology and trying to grow. So at VITS, we came up with another product that was called inverse multiplexing. And we had the ability to run 4 T1s to a business and bond them together, giving that company the equivalent of a 6 meg pipe, which is the fastest we could produce at the time, to their business. And again, anybody that wants to operate on a 6 meg pipe today would laugh a company out of the office, because every company out there and every home out there has substantially more bandwidth than that. Mark and I were talking this morning.
Yeah.
At my house, as an example, I have the fastest entry link I could get is an 80 meg pipe, which is actually 2 40 meg bonded, each one using 2 pair. And Mark has to his house.
I have Cox fiber, so I do the Gigablast with Cox.
Yeah.
And it's fiber optic gigabyte internet to the house. And, that way we can run the TVs and do what it is that we need to do. Our current system administrator, Nick, has talked to me about how with Cox, he doesn't like it great. It's okay, but he would much rather get a different service, and that's because he runs up against their data cap limits. Cox has a 1.25 terabyte data limit per month.
Oh, my word.
And both he and his wife like to do gaming online. And when you're doing gaming online with these game consoles or with the PC, either one, you're streaming tens of megabytes a second, and you can be upwards of 10 to 15 gigabytes an hour. And if you're doing a lot of it, even more than that, and they start running into data caps.
So when you run into a data cap on those games, I assume then that you're the guy that gets killed and you have no longer the speed or ability to kill the next guy in the bang bang shoot 'em up games.
Well, and for the people that are not necessarily our age, you tell us what POTS line is.
Thank you. It's a 64K standard phone line to a home or even your business. Stands for plain old telephone service.
Yeah.
And originally, POTS lines were just 2 out of the 4 wires that came into your home, and the other 2 just sat there twisted up behind the wall. And obviously, as that technology is gone, those POTS lines are still in the ground. They're still going to everybody's home. And so when CenturyLink came out to hook up my service, because at the time I couldn't get Cox, I can now, but regardless, they used all 4 wires to each one tied back to their D-slam, gave me a bonded 80 meg pipe to my house, which is ample for what we need today.
Yeah, so when people would first, I'll talk about a T1. Back in the day, it was not unusual for a T1 to be $600 a month. And you'd think, holy cow, $600 a month, that's so much money. But if you could get 24 phone lines off that $600 a month, you're only talking about $27 or $28 a month per phone line. And the phone company usually at the time would charge you between $45 and $50 per phone line for telephone service. So if a company was getting larger, it was to their advantage from a cost perspective to go to this newfangled data T1 thing. And it was a pretty cool thing for businesses.
Yeah. On top of T1s, we were also running DSL through digital subscriber line access muxes, ADSL. And again, that was just a great technology to start serving more and more businesses. The only drawback on those, I think that the copper length for most COs at that time was 16 to 19,000 feet. And the further away you were from that central office, the ELEC central office, the poorer the condition of that copper line got. And so there was clear limitations of how much bandwidth you could serve anybody at that time. And obviously, as in the data networking side, the same thing happened here. Companies like Verizon today or CenturyLink, they start putting more of these muxes further and further. Those are the big boxes that we all see in our neighborhoods or new neighborhoods. And those are backfed by fiber. And fiber is the way to carry that distributed network capabilities.
Definitely it is. In fact, if we're ready to do a transition, one of the vendors that we have with fiber optic cable is Corning. And I thought that would be a good way to transition into kind of spotlighting why did we choose this vendor, who is this vendor, and how did they come about in the fiber business too. Once we get through that, if time permits, we'll even get to what some of Corning makes and why we have some differences here. So Corning, when you think about Corning, if Jesse, you wanted to put up the Corningware dishes picture, Corning is a glass making company. They make things like these fancy old dishes that your grandmother used to cook casseroles in. By the way, those Corningware dishes, I could buy one to that set right there today, $140 on Amazon. I'd be there at my house this afternoon. I pulled this picture off of Amazon of all things. So when people think of Corning, they think of this type of stuff. This company gets its name from the town where it was at. The town of Corning, New York was founded in the 1800s, and it became known for its glassmaking. So there were many glassmakers there, and the Corning company has turned into one of today's leading fiber optic manufacturing companies. Corning is a remarkable company. They, just as a quick aside, they invest 10% at least of their annual gross revenue in research and development. And they have been doing this for generations. That's part of their corporate culture. Corning looked at developing a specialized glass product in the mid-1960s that they wanted to call optical fiber. What was happening in the mid-1960s is that surgeons had learned how to take glass tubes and use those glass tubes, especially if they had been painted, to basically bend lights that were coming into the room and be able to focus light on an area for surgery. In the mid-1960s, a Dr. Charles Cow presented a theory that if light from the recently developed laser technology could somehow be routed through these glass tubes, and the tubes could be made small enough and long enough that it would be possible for that light to transverse from one end of the tube to the other end, and it would be possible, in theory, for data like telephone calls to be put into the wavelengths of light where they could be basically turned from an analog to a digital signal. The light at a certain wavelength would carry that signal potentially over long distances, and then on the other side there would be a piece of hardware that would turn that digital signal back into analog signal. However, he said at the time, there is no glass that is capable of doing this. It's impossible because it's only theoretical. There was nothing nearly pure enough in terms of glass that could make that type of connection. So Corning took on the challenge. Some of their research and development team said, we're going to figure out how to make an optical fiber that will achieve what Dr. Cow wants.
We're glad they did.
We are glad they did. It took them almost 5 years of research to get to anything that was any longer than about 15 centimeters worth of light. One Saturday evening, a researcher was about to go home, and he decided, looking through one of these optic cables in 1970, he pulled it up to the microscope, took a look through it, shot a low-grade beam of light on the other end, and saw that light coming clearly through there. And that's when they knew that they had their formula right. They'd been working on it for 5 years at that point. It took them almost 10 more years to actually get their first customer. In that time, they obviously did lots of testing, and that was how the fiber optic got started. One of the truly amazing things about fiber optic cable that I learned as I was doing some research for this is that fiber optic cable's bandwidth is still today almost completely untapped. In theory, because there are so many different wavelengths along the light spectrum, if we could capture all of those various millions of wavelengths that are on the white light spectrum, put data onto every wavelength and send it, one single strand of fiber could carry all of the data on the internet. That blew me away, and it's actually more of the hardware on either side being able to distinguish and read the different wavelengths that's caused the changes that the technological limitations that we have in fiber today, and not necessarily the cable itself. So making glass for fiber optic cables like this, it's a lot different than just making glass for like a window. You don't take a bunch of silica sand and heat it up in a vat, melt it down, and pour it out, and then you have glass. In this case, make fiber optic cable, they heat up the specialized sand particles, and it makes a glass soot. These glass soot particles get deposited onto a rod in a highly controlled process. Both the gases that are used and the temperatures that are used and the timing that it's used are very tightly controlled, and you end up with thousands of layers of this glass. Each different type of temperature, time, or gas that gets used makes a different type of ash and ends up with a different property on the glass. and you end up with a glass blank, something that might be 2-3 inches around. The center will be a little different than the outside, though. Once that glass blank is done, it is then gone. It goes through a process where it's again heated and it's extruded into what we know of as fiber optic cable today. The fiber optic cables, as far as their size goes, if Jesse wanted to put the Corning Fiber human hair picture up, they have a good example of what a typical fiber optic cable would be in terms of width. So on the left there, you see a human hair. The middle is a typical fiber optic cable, an optical fiber cable, and the right is going to be fiberglass. And then if you wanted to look at the core and cladding picture, there are two parts to a fiber optic cable. You can see that a little bit there, and as this next one comes up, the first part of the fiber optic cable is called the core. This is where the light passes through. The other part that is called cladding is also glass, but its job is to act like a mirror. So light bounces through these cables, and it's going to bounce in whatever direction. Sometimes the direction is out. It gets into the cladding reflects the light back into the cable and lets it continue forward at, of course, the speed of light. Susan Crawford in Wired magazine actually wrote a good article about this, and it was an excerpt from a book that she had about technology and fiber optics and where it's at and where it's going. The thing that blew me away on it more than anything else, again, was the capability of fiber optic cable. We are still 50, 60 years later, just really scratching the surface. And I did not know that.
Again, what Mark was just talking about back in 2000, 2001, at VITS, the conventional wisdom at that point was for companies to run as much fiber as they possibly could. You couldn't put enough fiber in the ground. And then they came along this technology called dense wave division multiplexing that allowed you to basically take all that fiber and break it into the colors of the spectrum. And I think at that point we were using 7 or 8 colors, and each one able to carry full duplex, a signal from end to end. And now, as Mark pointed out, the technology I think today is able to carry 80 different colors, and it's almost infinite of what the capability is looking into the future.
Yeah, it definitely is. You know, it's on a computer screen. It's not unusual to hear that your screen is capable of displaying 16 million plus different colors. Well, each color is a different wavelength. And so each of those different 16 million colors could, in theory, be put into a fiber optic cable and be run through that cable with its own unique data stream. So you could have 16 million data streams going through one cable. IT Manager has a great question here, I think, where he says, the concern has always been that Wi-Fi will replace copper or fiber. What are your thoughts?
I don't see it yet, but never say never. At least and Mark's much more of an IT background than myself. But Wi-Fi, I don't think has yet the security and the speed capable of doing what you can do on wireline, being copper or fiber. So I think copper and fiber are going to be here for a long time to come. Again, the big corporate data centers that we support and selling this into, it is still a patch panel, patch cable capabilities on the copper, and the fiber, again, is going between computers and various sections of these centers. So I think fiber and copper are here for a long time to come.
I think they are too. I realize that microwave technology has advanced greatly, and you can get multiple megabits worth of data on, or gigabits worth of data across a microwave connection out in the wild, out in the world. But at some point, that infrastructure has to get to a wire. I don't see where we're going to get to the point ever necessarily with the size of our world as it is, where the efficiency of a light beam going across a fiber optic wire is going to be beat. There is something in copper wires called attenuation. And attenuation basically is simply it's it's almost like electronic noise. And it leads to the drop or loss of a signal. In copper wire, there's usually enough attenuation after about 100 meters, for example, that you cannot run reliably even a 1 gigabit network after about 100 meters or so. Single mode fiber cable has such a small loss in attenuation that you can go several miles before you have to have something that essentially repeats the signal. Yeah, we call it a repeater. And that's how you're able to have things like fiber optic cables that are going across the ocean. Now, in terms of the growth of fiber optic cabling, one of the articles I was reading about in current news for fiber optic, I did not know about. The state of Alaska in the United States still does not have a fiber optic cable laid between it and Seattle.
We can run one between the East Coast and Europe, but we can't do one to Alaska.
We can do one, but yeah, part of that probably is population and cost, return on investment. So technologically, we can do it. We have one between Asia and the United States. That's a lot longer distance and goes through a lot deeper ocean. It is in the process of being laid, but that gives you an idea. There are many areas of our world where the efficiency of the hardware, the fiber optic cable, is still there, but the cost has been prohibitive in the past. Over time, those costs are not going to be as prohibitive. While it's possible that wireless will still be there, those wireless pieces of hardware, that infrastructure, has to be built out. It's going to be susceptible to weather. It's going to be susceptible to sabotage, depending on where you're at in the world. It's going to be susceptible to all kinds of things, where a fiber that's buried underground is not susceptible to those things. Wireless is susceptible to security. It's much easier to tap into a wireless signal than it is to tap into a fiber optic signal.
You sure it's not the Alaskan king crabs cutting that wire while it was being laid down there?
I don't think it is, but you never know. You never know.
Hey guys, I think the only real company out there doing serious, impactful wireless on a massive scale right now is Starlink. And they're figuring out quite a bit and getting us all those areas where we don't have wire laid yet or fiber laid yet. We're talking tops of mountains all the way out to middle of nowhere in the desert in Africa somewhere, you know what I mean? So I think it's going to be a combination of both, actually, is my opinion.
Well, they claim, at least Starlink does, that they're going to have the entire globe covered in a very short period of time. And I don't know about anybody else, but if you go outside at night, and you can actually pull up an app to tell you this, but you can see what they call the Starlink train going across the sky. And it literally is satellite. You wait 2 seconds, here's another satellite, all going in the exact same path. And they do that until they get out to such an orbit that they can space them out. And but you read quite often that there is yet again another ship going up, another batch of Starlink satellites going up to cover this.
Yeah, and I think, Jesse, you're probably right. Overall, it's going to be a combination. There's Starlink is going to suffer some of the same deficiencies that I was just talking about. Not so much data integrity, but data security. While the satellites have a large bandwidth, their bandwidth is pretty fixed. And that's something that I can't emphasize enough. Their bandwidth is fixed. Fiber optic bandwidth, we still don't really know the limits to what we can get. And so as more fiber optic gets put into more neighborhoods, the ability to reuse what's currently there as well is going to only increase capabilities.
You look back on the networking industry, and it wasn't too many years ago that everybody thought that if you bought an Apple, it was much more secure than any other computer system. And the reason it was more secure was that there were less people trying to figure out how to hack it. And that obviously changed over time, and people realized Apple is just as susceptible as any other computer company out there. The truth is they can't really hack into a fiber optic cable. And so the Wi-Fi side of it, who knows? The more that this technology continues to emerge, the more people are going to try to hack into it and figure out how to steal all your money.
Yeah. You know, IT manager has one other comment. It says the FCC manages our airwaves fairly well, but there are limits with finite frequencies available including the necessary buffer between frequencies. That's very true. You know,
Indeed.
I saw that. I'm a sound engineer on the side, and wireless microphones up until 2.5 years ago, 3 years ago, almost now, all wireless microphones sat in a frequency band between 596 and about 650 megahertz. And wireless microphones now sit between 540 and 580 megahertz. The reason? The FCC auctioned off that 590 to 650 megahertz frequency band, and it's now used by Verizon and T-Mobile and AT&T and the other wireless carriers for their 5G network. The reason that it's used by them for their network is because there was nothing else available in the frequency band. It's one of the last frequency bands, is my understanding, that was available that had that much width and capabilities. So, well, we're getting close, Greg.
Yeah, the only other comment I wanted to make was, last week Pete talked about Gruber in its beginning days and silver satin, and then going up to Cat 3 cable, and one of the pioneers on twisted pair with inside of that Cat 3. And obviously, the world now has gone years on using Cat 5, Cat 6, Cat 6A cable. Cat 7 and Cat 8 are not standards yet. Things people are playing for. Cat 8 is largely being looked at with the inside of a data center between servers. But I think most of these companies realize they get much more bang for the buck in speed through a fiber optic cable than they are through a Cat 8. But the point is, this technology is still nowhere, the end is nowhere in sight. What we thought, was great technology, 40 years ago, 10 years ago, 5 years ago, last year, is becoming quickly obsolete because every day that technology curve just keeps getting steeper and steeper.
It really does. Now, one of the last things I do want to go through before we leave here has to deal with the different modes of multi-mode fiber. A multi-mode fiber is a larger fiber strand that carries more wavelengths of light. A single mode fiber typically carries one wavelength. It's an incredibly thin piece of fiber, and the advantage of it with carrying just one wavelength of fiber is that you can go several miles. Multi-mode, you cannot. The advantage of multi-mode is that you can carry several wavelengths, which enhances the data speed. So I've got here 2 fibers. One of these fibers is OM3, which is optical multimode generation 3. The other is OM4. It's the Gen 4. It's a little bit faster speeds. What's the difference that you can see between these two cables, not counting the connector, obviously?
They're both aqua, and they both look absolutely identical.
Exactly. Now, what is that you have there?
This is our OM4 Violet. It started off as a European standard, but we have adopted it. And the reason we adopt this violet color, for the same reason as a standard OM4, is that in any company's data center, they now are able, it's mixing with that background, but anyway, in a data center, you can now pick out what is your OM4 connecting cable much easier than the violet one. It is a true differentiator and been a great product for us.
It really has. And again, for those listening, unlike copper cables, which can be rainbow colored if we want.
14 colors, oh yeah.
The fiber optic cables tend to be very standardized in both their in their color. So aqua will be OM3 or OM4. Yellow is going to be OM2, and OM1 is typically going to be orange.
Indeed.
So We're at the hour already. Thank you guys so much for listening to us. I really appreciate all the comments today. It's been a good day for us.
Absolutely. Thank you for letting me on, and we will see if Mr. Gruber returns next week. Thank you.
Take care, guys.